So precipitation reactions occur when mixing two aqueous ionic solutions. And the precipitate that forms is based on the solubility of the products. If a product is insoluble, it will precipitate in the situation. So precipitation means to fall out of solution, and it becomes a solid that you can see in the reaction mixture. Those substances that have low solubility are likely to precipitate. So when you're looking at compounds and you're looking at a solubility table, those things that say slightly soluble, those are going to form a precipitate. Okay, those compounds that are highly soluble will not form a precipitate in aqueous solution. So some simple guidelines here is that, so when we take a look at these ions, we can see that these cations, for the most part, they are going to be soluble in water. Mainly, we're talking about the solubility in water, because if it's an aqueous solution, we're mixing two ionic aqueous solutions. Aqueous means that water is the solvent. So we are always talking about in these precipitation reactions. For this course, we're talking about those reactions that take place with water as a solvent. So what this means is that these ions are soluble in water, regardless of who they are bound with in a compound. These anions are considered soluble except when they're found in compounds like this. So let's say silver chloride is not soluble. Mercury 2 bromide is not soluble. Okay, these other anions are soluble except when they're found in compounds containing those cations. Another more comprehensive solubility guidelines rules can be found here, where we see on the left-hand side is the rule. So let's say sulfides are insoluble except when formed in compounds containing these cations. So let's say magnesium sulfide is soluble. Calcium sulfide is soluble, okay? And ammonium sulfide is soluble. Some sources say that these might be slightly soluble. If I'm going to ask you a question on an exam, it's going to be clearly delineated that you can tell whether that compound is soluble or not. Remember we said slightly soluble really means that for the most part it's not going to dissolve. So generally doesn't dissolve. Okay, so things that are slightly soluble, as I mentioned before, are generally don't dissolve, and they're likely to form a precipitate. Okay, so slightly soluble are most likely going to form a precipitate. There is, let's see, what is the other thing that I wanted to show you here? No, that's not. So when we look here where it says lead halogens are soluble in hot water. So in hot water, they're soluble, not at room temperature. So at room temperature, which is anywhere from 22 to 25 degrees Celsius. So that means if we're carrying out this reaction at room temperature, we're not heating the reaction mixture, then these lead halogens will form a precipitate, okay? In this video, we're going to cover some practice on determining whether compounds are soluble in water and looking to see if a precipitate is formed and how to determine whether a precipitate is formed or not. In lecture, we covered the solubility rules and how we can read the solubility rules to help us determine if a compound is soluble or not. So now we're just going to do a little bit of practice on this concept. If we go back to our solubility rules, we can see that sulfides are insoluble, and there were no exceptions to this rule. So this compound would be, well, it said most sulfides are insoluble, and we didn't see an exception. So this is going to be an insoluble compound, and it would form a precipitate if it was a product in a reaction. What about 10(2) carbonate? Well, the rules say that most carbonates are slightly soluble. So this guy's a slightly soluble situation, and based on the information that I gave you during lecture, slightly soluble compounds will generally form a precipitate during a chemical reaction. All right, how about you take a moment and pause the video and try to solve C and D on your own. And when you come back, we will take a look at the answers together. All right, so what about barium nitrate? Well, from the rules, it says that all nitrates are soluble. So this guy would be soluble, and no precipitate would form if it was a product in a reaction. Let's try, instead of doing aluminum sulfide, how about you try taking a look at aluminum chloride? All right, what about aluminum chloride? What can we say about aluminum chloride? Well, the rule says that most halide salts are soluble, and aluminum was not on the list of exceptions. So this guy is soluble, and it would not form a precipitate if it was a product in a chemical reaction. All right, so let's practice here determining if there is a precipitate when we're taking a look at a chemical reaction. So will a precipitation reaction occur when aqueous solutions of lead 2 chloride and ammonium sulfide are mixed? First, we have to write out our chemical reaction. And because we know that these are two aqueous solutions, we're going to have our swapping out of partners. So we end up with lead sulfide. We know that our lead charge is going to be a 2+ because I need 2 chloride ions, right, to make that compound. And we also know that sulfide has a 2- charge. So here's the compound for lead 2 sulfide, and we have ammonium chloride. We need to balance out our equation. So what can we do to balance out our equation? Yes, we need to put a 2 here in front of ammonium chloride. So let's put our little aqueous symbols down here. All right, so if we remember, if we go back to our table of guidelines, most halides are soluble and all ammonium salts are soluble. So this guy is not the precipitate, right? Because it's soluble. But lead sulfide is not soluble. Remember, the rule was that most sulfides are insoluble. And so this guy is going to be our precipitate. Okay? Here's a question for you to try. I want you to take a moment, try it on your own. Let's take a moment, try it on your own, pause the video, try to solve it. You've got your rules here, and we'll come back and we'll come back and then check your answers when you're done. Okay, so what did you come up with as your answer? All right, so we've got sodium phosphate and we've got lead iodide. Well, says that sodium ions in compounds are soluble. So this guy is soluble. And even if you looked at the other guidelines page, you'll see that phosphate is one of those that's generally soluble, especially when they're mixed, when they're in compounds with group 1 alkali metals. However, lead iodide is not soluble because although compounds containing iodine and ions are soluble, they are not when lead is in the compound. So our answer is going to be B, soluble and insoluble. Here's another to try. So here you're going to determine what the products are and then decide whether they are soluble or not. So how about you pause the video and solve the problem, and come back and find out the answers. Okie dokie, folks. Let's take a look at the first example. All right, so for number 1, let's take a look. What will be your products? You will end up with, let's change my pen color. You will end up with, remember these are double displacement or double replacement, so everyone swaps out their partners, and we're going to end up with CrCl3 and potassium nitrate. Don't forget your, you know how to write these compounds because you know what the charge is on these ions. We need to balance out our reaction. So we've got to put a 2 here and a 2 there. Now our reaction is balanced. If we take a look at our rules, halide salts are soluble. So, and chromium is not on the list of exceptions. And we know that all nitrates are soluble. So there's no precipitation reaction for A. Let's swap out our partners for number 2. We get silver bromide, or silver, that's not silver, mercury 2 bromide, and we end up with sodium nitrate. We need to balance out our equation. We've got to put a 2 here and a 2 there. Well, we know that halides are soluble except when bound to mercury, silver, and lead. So this guy is going to be solid, and our sodium nitrate is going to be aqueous because all nitrates are soluble except when they're bound with these cations. All right, so there's a precipitation reaction there. And let's do the last one. We get ammonium sulfate. How do I know that I need to have 2 ammoniums? Because I have 2 sodium. So even if you didn't remember what the charge was on sulfate, you know that it has to be -2 because we have 2 sodiums in that compound. And our other product is going to be sodium bromide. Let's take a look to see if everyone is balanced. Nope. We need to put a 2 here and a 2 there. Now we're balanced. Ammonium salts are all soluble, so this guy would be aqueous in solution. And sodium bromide, we know that all bromides are soluble except for when bound to these heavy metals. So this guy is going to be an aqueous solution, and our answer is B. Okay? So hopefully you understand how to determine whether you have a precipitation reaction, and also how to determine whether an ionic compound is soluble or insoluble in water.